Okay, so in this video I'm going to introduce assemblies in Autodesk Inventor. Inventor is kind of set up really for bottom-up modeling, which is where we are going to collect a bunch of parts we've already made and assemble them together, kind of like Lego blocks. So what we're going to start off with is we're going to go for a new file. Make sure when you do that you select the metric tab and that you've selected the standard millimeter template. If you don't do that, you're going to end up with inches or some other problem. So make sure it's this one you've selected and then press create. So once you're in here, you have opened up a blank workspace. We've got our view cube as per normal, and just worth pointing out that we've got in that workspace there are our planes, so our imaginary workbench and kind of walls that we're going to use to constrain the parts to. So first thing we want to do is collect the parts that we're going to assemble together. Inventor does that by using this place command. So either we can hit the button up here, or we can hit the P. There's a couple of options as to what we place. So we can place Inventor components, so Inventor parts that we've already modelled. That's what we're probably going to do most of the time. Other thing we might do is place imported CAD files. So if we've made a model in Onshape, for example, and we've exported that as a step file, we can then import that into our assemblies here. We may occasionally use the content center, so that is a CAD library full of standard parts such as nuts and bolts and a whole range of other things. So rather than modelling a nut and a bolt ourselves, we could use one from the content center. So if we go ahead and click the place button, that's going to give us a location for our files that you could navigate to where you've saved your Inventor files, your Inventor parts, and then you can select the one you're going to use. So I'm going to start by dragging in one of these here, and when you first open it, you'll see you end up with your part sort of stuck to your mouse, and you're going to need to drop it in place. So if I just click the left button of my mouse, it's now dropped it in place, and I've got another option to put more parts in. I don't want to do that, so you can either right click and hit cancel, or you can press the escape button. Now this first part, if I drag it around, you can see it is mobile. It's not actually locked down to anything. So the first thing you want to do is you want to find your part over on the feature tree here. If we right click, we can ground it. So hit the grounded. Now you see you've got a little pin next to the part in the feature tree. If I come over here, it's telling me it's grounded. I can't move it, and there's a little icon there showing a little pin. So that's now going to be suitable for us to add other parts to it, connect other parts to. Just one thing to draw attention to at this point: if you look at your feature cube, sorry, your view cube, when I drop that part in, it's spun around so that the front view is now facing up. I don't know why Inventor does that as a default, but it's a bit of a pain. What you want to make sure that is that when you have got your part in, that the front is facing the front and the top is facing the top. If it isn't, then you'll need to use the constraints and do that kind of manually. But if you have modelled your part correctly, so that the top of the part is up, the front of the part is to the front, etc., then it should drop in fine. Just be aware of that, because it makes life easier when you go on to add shadows and things to your view. If the shadows, if your part's wrong around and the shadow is falling on the ground, it looks like it's falling on the wall. It just doesn't make quite so much sense. Okay, so that's our first part done. What we can do now is add further parts into this assembly, and then we're going to have to use constraints to connect them together. So we have created our assembly, we've added our first part, and we've grounded it. So at the moment it does not move. It's really important that our first part is the right way round and is locked, so that our other parts can be connected to it. Next we need to add a second part, so we're going to place, and we're going to search for the component, and we're going to open it. We're going to click once on the screen. If you want more than one, we can add more than one, but probably most of the time you're just going to have the one, so we can either press the escape key, we can right click and cancel. Now to join these together, to stack these like blocks, we need to use constraints. And the first constraint we're going to look at is the mate constraint. The mate constraint is basically going to connect surfaces together. So if I come up here, I can either click the button, or I can use C on my keyboard as a shortcut. and I get this box. We're going to use this first type, and we're going to use this first solution here. So this little icon shows 2 blocks touching. That's the make command. That's what we want. And in order to make it work, we are simply going to come onto our shape, click on one of the surfaces. I want that surface to connect to this one here. Let's connect them, and if I spin the block round, you can see those 2 surfaces now are lined up. If I just bring it over here, you can see that they are connected. I can still move the block though, but they are now moving in line. Just a little by the by, if you press the F4 key, you can get the orbit tool, which means you can view, you can drag your mouse and move around the model. I find it a little bit easier than always going over to the view cube. You can also access the orbit key here, sorry, the orbit command here, but you've got to click it and then click it off, so it's just a bit of a drag. So F4 key allows us to turn it. So we've got one of those mate constraints. Obviously I need more because it's still floating around. So I need another one. This time I'm going to select that face there, and I'm going to select this back face of the white block here. So again, if I press the constraint button or use C on the keyboard, I'm going to select that face, hit F4, turn it round and hit that face there, and it's jumped in place. I'm going to press OK. So you can see now I've got 2 surfaces are connected. This one here, these 2 are connected, and these surfaces here are connected. So I'm nearly done. As you can see though, my block is still sliding. Now, in order to fully constrain that, I need to line up this end surface here with this end surface here. To do that, I'm not going to be able to use a mate constraint. To mate it, I would need somehow to get that part so that the face here somehow turns around and touches that without letting go of these, which is physically impossible. So we're going to need to use a different constraint. Just while I'm here though, I'll show you what happens if I try and do it, because you may come across this. Select that face, select that face. I've still got the mate selected. I know it's impossible. If I click apply, I get this pop up. The assembly cannot be solved. What that means is you're trying to connect 2 surfaces, or you're trying to put a mate in place, a constraint in place that cannot physically happen. Best thing to do is either go back and edit it or cancel it. Very rarely would you do this one here, because you're going to end up with all sorts of problems later on. If it comes up, you're doing something that's physically impossible, so cancel it and think again. So in this instance, I'm going to stop, and I'm going to move on to looking at the next type of constraint that will allow me to line these 2 up. So to complete this assembly, what we need to do is we need to line up these 2 surfaces, and to do that we're going to use an align constraint. So go through the same process before, picking up the constraint tool, select the 2 surfaces that we want to line up, but this time here, rather than using the mate where the 2 surfaces are touching, we're going to use this one here where the 2 surfaces are aligned. Now Inventor calls it a flush, SQA call it an align constraint, so you need to try and remember that you're going to align the 2 surfaces. If I hit that, you'll see that the 2 parts have moved so that they are now in line, they're flush together. If I just apply that and turn around to show you the view from here, you can see that those parts are now completely aligned, and that the 2 parts here as well are now completely constrained. I can no longer move that. Okay, for this assembly here I've got 2 parts. Both of them have got a cylindrical element, so I want to put this cylindrical peg here into this hole, and in order to do that we're going to use a center axis constraint. We'll need to use other constraints to fully lock the 2 parts together, but we'll start off looking at the center axis constraint. So as before, we're going to use the constrain tool, so we can either click the button or we can hit the C on our keyboard, and the constraint box comes up. We're still going to be using this, what Inventor terms a mate constraint, but as you'll see, the options for the solution will change shortly. So all we're going to do is we're going to hover our mouse over the cylinder, and you'll see we get a center line and an arrow showing us the axis Any cylindrical surface would have it, so that slightly wider one also, and then if I come here you can see that the hole does as well. You'll notice that the hole, the axis is pointing down, and for the peg the axis is pointing up. It doesn't really matter, but you'll see what happens shortly is because of the direction of those axes. So if I click on the peg first, and then I click on the hole, they will connect together, and you'll see here we've got three options for the arrangement of the two parts together. So this one here is put it in, it's called it opposed. You see the two arrows are facing different directions, and that's actually what we want, because the larger bit here, this sort of top, if you like, of the peg is sticking out. If I hit this one here, the aligned one, that's going to have the two arrows going the same way. In our situation, we obviously don't want that. This is a new feature for Inventor 2020, and it's really helpful because it allows us to flip it. Previous versions you'd have to use mates and other ways to do that first. So make sure that you've got your the correct axis selected, and make sure it is the right way around, and you can go apply. That is the center axis constraint. So any cylindrical object can be joined in that way. I'm just going to keep going with this part though to show you how you can add further constraints to lock it down. So if we look, all we have actually achieved is lining up the two parts along that common axis. We've not set a distance here. This isn't joined to anything. We've also not limited how it can rotate. So two ways that we can lock that. Again, using the constraint tool, I'm going to start by selecting the bottom of the hole, and I want the bottom of the peg to touch the bottom of the hole. So if I put those two together, I'm going to go for a mate, and that's going to stick those two surfaces together. So we can see here, if I just OK that and show you a hidden edges, you can see that the peg here is in line with the hole, so it's joined to the bottom. Just turn that off. So is it constrained? Well, it is now in line, and it is also stuck to the bottom, but it can still spin. Now if you've got a part that is cylindrical, there's nothing maybe on here that you can pick up for in terms of a surface to mate something to. This one has actually got a surface on it, but often you may have a round surface that you don't know how to constrain. So what you want to do in that situation is to use the planes that exist within all the parts, and pick out the ones that you want to align. So for this here, if I just expand each of the parts, you can see they've got an origin, and if I expand the origin, I have the three planes and the three axes that we have when we start creating those parts. So for this situation here, what I'm going to do is I'm going to go for constrain. I'm going to select from the block one of these planes, doesn't matter which one. It's not going to be the bottom one, that won't help me, it's going to be one or other of these two, so let's just pick that one. And now I'm going to do the same for the peg, the second part. So if I hover over here, I can see there's a plane. If I click that, it's going to mate those two planes together. So it's join them up. If for some reason I wanted it to be the other way around, I could turn it into this calls it a flush, but we call it an align mate, and that would actually spin it round. You're not going to see any difference because it's symmetrical. But if it comes in the wrong way, we can use those. So if I apply that, I should now have a part that is fully constrained. We've got the center axis down the middle, we've got a mate at the bottom, and then we've also got a mate or an align between the two planes that run between within each of these two parts. So that is now fully locked down. Okay, in this assembly here, I'm going to constrain this top block. I've already got a mate constraint between the bottom of it and the top of this lower one, and I've got an align constraint between this face here and this face here, so it's nearly constrained. What I want to do though is I want to position it somewhere in the middle, rather than it being stuck to the end. And to do that I need to use an offset constraint. So it's quite a useful offset constraint to position two parts within relationship to each other but not necessarily touching. And to do it, it's very straightforward. I'm going to go for a constraint. I'm going to hit this face here and this face here. Now they are going to be an align, which is that one there. because of the other constraints that are on them. So if I hit that, you can see it's going to end up lining the two up. And here you've got a little box that's titled offset and an option to put in some numbers. If I put a number in there, you can see it's going to create an offset, a distance between those two surfaces. If it comes out in the wrong direction, you can add a minus sign and it'll flip the direction and push it in the opposite way. For what I want here, I'm going to go for 25, should put it in about the right place. So if you need to have two parts lined up but separate or distanced, it's an offset constraint you're going to use. So I'm going to make a few changes to this assembly I put together earlier, using the center axis constraint to insert this peg into a hole. I locked it up so that this here is parallel with this side, but I now want to change it so it's put it at an angle. Now in order to do that, first thing I need to do is to find the constraint that's stopping it rotating, remove it so I can put the one I want in. So like other parts and in Inventor, if you expand the elements in the feature tree here, you can find the ways that it's made up. So here, if I expand the second block, which is this pin, you see I've got the mates appearing that I used earlier. So if I hover over them, I get a little indication of where those mates are. I can actually edit them, I can delete them, I can do various different things to them at that point. This one here is the one I'm interested in. It's the plane from this bottom block is mated to the plane within the top pin. So I want to delete that, so I'm going to right click on mate 4 and delete it. And that means I can now spin stuff around again. So this time what I want to do, to set it an angle, an exact angle, I'm going to use the Orientate constraint. That's what SQA call it, and we're basically going to set it at an angle. So to do that, it's very straightforward. We're going to go back to our constrain tool. This time, instead of using the simple mate sort of element here, we're going to go along one to where it says angle. We've got three options for the solution. We're going to select the first one here, and what that is going to ask us for then is two surfaces or planes, and then it's going to set an angle between them. So if I go ahead and hit one of these side faces here, and I come up and maybe hit the side there, it's going to sit them at 0 degrees just as a default, but if I type in a number, it's going to add those it's going to add an angle between them, so I can obviously change that until I'm happy with the number. If I apply that, then that's my part set at an angle. Now in this instance, there's a flat face on the part, and I've used that to drive the angle. If we didn't have a flat face, if it was cylindrical, maybe there were some buttons or something on top, we wouldn't be able to do it quite that way. So I'm just going back in and I'm going to edit my my constraint. So here, if I got rid of that first one, okay, I want to hit something here. Obviously I can't select the curved surface, so what I'm going to do instead is I am going to pick up one of the planes. So again, as I did before, I could pick up that plane, or I could pick up this plane here, and I can set an angle between them. So I could make it wherever I like. So if I haven't got something, a feature on the part that I can select that's flat, I can always find the planes and I can use them instead. So that's the Orientate constraint, which allows us to set parts at a set angle, set them off each other at a given angle. Okay, in this example I'm going to look at a final constraint, which is the tangent constraint, and this allows us to connect curved surfaces. So I could arrange this blue disc so that the edge surface here is touching the edge of this pin. I've already constrained the disc using a mate constraint so that this is touching, so it slides just on that surface. I just need now to use the tangent constraint to lock it to these two pins. So I'm going to go constraint rather, and this time along here I'm going to select the tangent option in the type of constraint, and if you look at the solutions available, we've got an outside, which is what we want here, which is where the two outside surfaces are touching. We've also got an inside, which may be useful for example a peg in a hole. Simply we're just going to select the two edges and it'll jump in place. If I just to show you, if I hit the inside one, you can see where it sits. We obviously don't want that, we want to go for the outside. I'm going to apply that. I'm going to do the same for the second peg, and that will now locate that disc so that it is touching. And if I just close that and show you the view from above, you can see that these two pegs here are touching the edge of the disc.